In the heart of the Taklamakan Desert, shimmering bodies of water now break the endless dunes, an astonishing reality, not a mirage. These oases are the result of China's bold and controversial initiative, introducing fish into its most arid regions. The project aims to combat desertification and create new economic opportunities in some of the nation's harshest landscapes. Could artificial ponds, stocked with resilient fish, trigger positive environmental change in a place known as the Sea of Death? Massive water diversion and advanced aquaculture technology have turned this vision into one of the world's largest ecological experiments. The goal to see if these aquatic ecosystems can boost local humidity, improve soil, and support more diverse plant life. Proponents imagine deserts transformed into productive oases, supporting agriculture, tourism, and new communities. But the results are as cautionary as they are remarkable, with the world watching closely. This is not just a story about fish. It's about water, survival, and the unpredictable relationship between human ambition and nature. As we explore this extraordinary endeavor, we'll uncover both the celebrated successes and the emerging challenges. To grasp the scale of this project, consider China's vast western deserts, the Gobi and the Taklamakan, where water is scarce and life clings to the edges of oases. The Taklamakan in Xinjiang is a cold desert with less than 100 millimeters of annual rainfall, its rivers fed by distant mountain snowmelt. Desertification relentlessly threatens these regions, pushing the government to seek radical solutions. Aquaculture sites are strategically chosen, low-lying saline lands or depressions where groundwater is accessible and evaporation is minimized. Projects near the Nanyuan Oasis and Kubuki Desert leverage local conditions to maximize success. China's 1.5 million hectares of saline wasteland, once considered useless, are now seen as a blank canvas for innovation. The fish stocking initiative marks a paradigm shift, turning wasteland into economic opportunity without competing for scarce farmland. This geographical context reveals the government's motivation to conquer inhospitable frontiers through technology and ecological engineering. The desert is no longer just a barrier, it's a proving ground for new ideas. Raising fish in a desert may seem absurd, but it's rooted in science. Desert aquaculture creates semi-closed ecological systems where fish waste fertilizes nutrient-poor soil, enabling the growth of salt-tolerant crops. Only hardy species, like tilapia, carp, and some shrimp, can survive the brackish, fluctuating waters. Selective breeding and genetic modification push these species to thrive in extreme conditions. Large ponds moderate temperature swings and increase local humidity, creating a micro-oasis effect. Scientific monitoring shows measurable rises in atmospheric moisture and gradual improvements in soil quality. Water management is key. Brackish groundwater is recycled through advanced filtration, often powered by solar energy. Water is reused for fish, crops, and even to recharge aquifers, making every drop count. This integrated approach is both a scientific and engineering challenge, aiming for long-term sustainability. The desert is being reimagined, one pond at a time. Turning desert into fish farms is a logistical marvel. Bulldozers carve vast ponds, lined with clay or geomembranes to prevent water loss. Water is sourced from deep wells or diverted rivers, delivered by networks of canals and solar-powered pumps. Millions of fingerlings are transported in oxygenated tanks, then acclimated to their new home. A steady supply chain brings in fish feed and equipment, connecting remote farms to industrial centers. Skilled technicians monitor water quality, fish health, and environmental conditions around the clock. Permanent housing, labs, and support facilities rise from the sand, creating self-contained hubs in the wilderness. Every step, from construction to daily management, requires precision and adaptation to harsh conditions. These projects are more than fish ponds, they're entire communities built from scratch. The scale and complexity are unprecedented in desert environments. The arrival of water has transformed the desert's ecology almost overnight. Migratory birds now flock to these artificial oases, turning silent sands into bustling wetlands. Around the ponds, green belts of salt-tolerant plants stabilize dunes and reduce erosion. Native desert plants are beginning to colonize these new habitats, carried by wind and birds. The result? A patchwork of life where there was once only sand. But this transformation brings risks. Fish waste and uneaten feed can contaminate aquifers, and non-native species may escape into natural waterways. The new ecosystem is artificial and requires constant human management. Scientists monitor everything from soil salinity to plant diversity, tracking both positive and negative trends. Algal blooms and invasive species are real threats, demanding careful oversight. The ecological story is still unfolding, a testament to both innovation and unpredictability. For desert communities, fish farms have been a game changer. They provide stable jobs, from construction to aquaculture, reducing the need for migration. A new local economy has emerged, with processing plants, logistics, and even tourism. Fresh fish improves food security and diets, while new infrastructure benefits everyone. Training programs equip locals with modern skills, fostering optimism in once marginalized regions. Yet, rapid development pressures traditional lifestyles and raises questions about who truly benefits. Large corporations and government entities often control the projects, sparking debates over local autonomy. The social transformation is profound, but its long-term equity remains uncertain. The desert fish farm's success comes with serious challenges. Brackish groundwater, often from fossil aquifers, is finite. Overuse could deplete reserves and cause land subsidence. New ponds have become breeding grounds for mosquitoes, raising public health concerns. High fish densities make disease outbreaks likely, requiring antibiotics and risking environmental contamination. Infrastructure fragments the desert, disrupting native wildlife and altering ancient ecosystems. The long-term ecological impact is still unknown, with some species benefiting and others threatened. Economic viability depends on stable fish prices and government support. Without them, these projects could collapse. Abandoned infrastructure would leave communities vulnerable in a changed landscape. The initiative has created new dependencies, tying desert futures to unpredictable markets and policies. Innovation here is a double-edged sword, progress and peril side by side. The world is watching China's desert aquaculture experiment. Countries facing desertification and food insecurity see potential in these methods. Solar-powered pumps, salt-tolerant fish, and integrated water recycling could be adapted globally. International delegations study China's successes and failures, hoping to replicate the model. But China's unique mix of state investment, centralized planning, and risk tolerance may not translate elsewhere. Environmental and social trade-offs must be weighed carefully in every context. Each desert is different. What works in the Taklamakan may fail in the Sahara or Outback. The lesson: adapt core principles thoughtfully, ensuring development doesn't come at irreversible environmental cost. China's desert fish farms are a breathtaking display of human ingenuity. They've created new economies, improved livelihoods, and sparked ecological change in the world's harshest places. But beneath the surface, serious questions remain about water depletion, ecosystem disruption, and economic fragility. The project is a grand experiment, its final outcome uncertain. As climate change and population growth strain resources, such bold solutions may become more common. These projects force us to weigh development against preservation, short-term gains against long-term risks. China's deserts are now a real-world laboratory for the future of ecological engineering. The shimmering ponds offer hope and a warning. Every solution brings new challenges. The ultimate question: in reshaping nature for our benefit, can we avoid destroying the very systems we depend on?